Have you ever wondered why the weather changes so frequently? Why it's sunny one day and rainy the next? Or why some areas experience extreme weather conditions like hurricanes, tornadoes, and blizzards? In this video, we'll explore the science behind weather patterns and how they affect our daily lives. A montage of different weather conditions, including sunny skies, rain, thunderstorms, hurricanes, and snowstorms. Weather patterns are the result of complex interactions between the atmosphere, the oceans, and the land. Understanding these interactions can help us predict and prepare for weather events and even mitigate their impact on our communities. A map of the world, with different weather patterns highlighted in different colors. In this video, we'll cover 5 key topics related to the science of weather patterns, the atmosphere, the water cycle, air pressure, wind, and climate change. So sit back, relax, and let's dive into the fascinating world of weather science. The atmosphere is the layer of gases that surrounds our planet. It's made up of several different gases, including nitrogen, oxygen, and carbon dioxide. The atmosphere plays a crucial role in regulating the Earth's temperature and protecting us from harmful radiation from the sun. An animation of the Earth's atmosphere, with different layers highlighted. The atmosphere is divided into several layers, each with its own unique characteristics. The lowest layer is the troposphere, where most of our weather occurs. Above the troposphere is the stratosphere, which contains the ozone layer that protects us from UV radiation. An animation of the different layers of the atmosphere, with the troposphere and stratosphere highlighted. The atmosphere is also responsible for creating weather patterns. The sun's energy heats the Earth's surface, causing warm air to rise and cool air to sink. This creates areas of high and low pressure, which in turn cause wind and other weather phenomena. An animation of warm air rising and cool air sinking, with areas of high and low pressure highlighted. Understanding the atmosphere is crucial for predicting and preparing for weather events. Scientists use a variety of tools, including satellites, weather balloons, and radar, to study the atmosphere and gather data on weather patterns. An animation of different weather monitoring tools, including satellites, weather balloons, and radar. In the next segment, we'll explore the water cycle and how it contributes to weather patterns. The water cycle is the process by which water circulates through the Earth's atmosphere, oceans, and land. It's a crucial component of weather patterns, as it helps to regulate temperature and create precipitation. An animation of the water cycle, with arrows showing the movement of water between the atmosphere, oceans, and land. The water cycle begins with the sun's energy heating the Earth's surface, causing water to evaporate from oceans, lakes, and rivers. This water vapor rises into the atmosphere, where it cools and condenses into clouds. An animation of water evaporating from the ocean, rising into the atmosphere, and condensing into clouds. When the clouds become heavy enough, they release the moisture in the form of precipitation, such as rain, snow, or hail. This precipitation replenishes the Earth's water supply and helps to regulate temperature. An animation of precipitation falling from the clouds and replenishing the Earth's water supply. The water cycle is also influenced by other factors, such as air pressure and wind. For example, winds can carry moisture from one area to another, creating areas of high and low precipitation. An animation of wind carrying moisture from one area to another, creating areas of high and low precipitation. Understanding the water cycle is crucial for predicting and preparing for weather events, such as droughts, floods, and hurricanes. In the next segment, we'll explore air pressure and how it contributes to weather patterns. Air pressure is the force exerted by the weight of the atmosphere and the Earth's surface. It plays a crucial role in creating weather patterns, as areas of high and low pressure can cause wind and other weather phenomena. An animation of air pressure, with areas of high and low pressure highlighted. Areas of high pressure, also known as anticyclones, are characterized by sinking air that creates clear skies and calm weather. Areas of low pressure, also known as cyclones, are characterized by rising air that creates cloudy skies and stormy weather. An animation of anticyclones and cyclones, with their respective weather patterns highlighted. Air pressure is influenced by a variety of factors, including temperature, humidity, and wind. For example, warm air rises and creates areas of low pressure, while cool air sinks and creates areas of high pressure. An animation of warm air rising and cool air sinking, creating areas of high and low pressure. Understanding air pressure is crucial for predicting and preparing for weather events, such as thunderstorms, tornadoes, and hurricanes. Scientists use a variety of tools, including barometers and weather balloons, to measure air pressure and gather data on weather patterns. An animation of different tools used to measure air pressure, including barometers and weather balloons. In the next segment, we'll explore wind and how it contributes to weather patterns. Wind is the movement of air from areas of high pressure to areas of low pressure. It plays a crucial role in creating weather patterns, as it can cause storms, hurricanes, and other weather phenomena. An animation of wind, with arrows showing the movement of air from areas of high pressure to areas of low pressure. Wind is influenced by a variety of factors, including air pressure, temperature, and the Earth's rotation. For example, the Coriolis effect, which is caused by the Earth's rotation, causes winds to curve as they move across the surface of the Earth. An animation of the Coriolis effect, showing how winds curve as they move across the surface of the Earth. Climate change is also affecting wind patterns and weather events. As the Earth's temperature rises, it can cause changes in air pressure and wind patterns, leading to more frequent and intense weather events, such as hurricanes and droughts. An animation of the Earth's temperature rising, causing changes in air pressure and wind patterns. Understanding the impact of climate change on weather patterns is crucial for predicting and preparing for future weather events. Scientists use a variety of tools, including climate models and satellite data, to study the effects of climate change on the Earth's atmosphere and weather patterns. An animation of different tools used to study the effects of climate change on the Earth's atmosphere and weather patterns. In conclusion, weather patterns are the result of complex interactions between the atmosphere, the oceans, and the land. Understanding these interactions can help us predict and prepare for weather events, and even mitigate their impact on our communities. Thank you for watching this video on the science of weather patterns.